All right, so over the last many lessons, so far in this chapter, we've been doing a decent number of problems kind of like this, but we've always had to do it either because we could actually graph f of x and see that it was like linear or something like that we could actually find an area of very easily, or we're working with these and this wasn't a nice easy graph to be able to find the area of, and so we did a Riemann sum with that. So we drew like all the little rectangles underneath and all that kind of stuff. Today we're getting the notes to be able to see how we can do this without having to rely on one of those methods. And so if I'm trying to find the integral from a to b of any function, I can do so by using what's called the fundamental theorem of calculus. And yes, it takes until over halfway through the year for us to get to the fundamental theorem of calculus. This is what that theorem is. Go ahead and write this into your notes, and then we're going to talk about what this really means and see it in practice. And so, using this formula, we're going to be able to find any of these integrals from a to b of a function that we can actually find an antiderivative of. And so notice how we do it. We find the antiderivative, capital F, and then we're going to plug our upper bound into it and take away, plug in the lower bound. So capital F of b minus capital F of a will get it to us. And this way we can actually do it for any old function, not just those where we can draw it in, shade the area, all that kind of good stuff. We're going to put it into practice first with this problem. So go ahead and write down this problem, and we're going to see how we can apply it to it. All right, now the first thing I need to do is I need to figure out what my antiderivative is. So I need to figure out what capital F of x actually equals. So I'm going to do the antiderivative here of x to the 100th power. Well, I'm using the power rule in reverse here, so that's going to be x to the power of 101. But remember, I then have to multiply that by the reciprocal of that exponent. So that's going to be 1 over 101. So I have 1 over 101 times x to the 101. And then this is the antiderivative, so we generally put a plus c there. All right. So in order to figure this out now, what I'm going to do is I'm going to be doing f of the upper bound, so f of 1, minus f of the lower bound, negative 1. So I need to plug each of those in. So when I do that then, for the f of 1, it's going to be 1 over 101 times 1 to the power of 101 plus c. So that is the f of 1 value. Now I need to subtract the f of negative 1. Now notice when I subtract it, I'm going to do minus, and then I'm going to put it all in parentheses. That's going to make your life a lot easier and help you avoid errors down the line if you always do minus parentheses and put everything in there. All right. So now I'm plugging in negative 1. So it's still going to be 1 over 101. And this time it's times a negative 1 to the 101 power plus c. All right. Now we can actually figure some of these out. For instance, what is 1 to the power of 101? Well, that's 1 times 1 times 1. That's a lot of 1 times 1s. But of course, 1 times 1, no matter how many times you do it, is going to give us 1. So that just ends up being 1 over 101. And then the plus c is still just hanging out there. And then it's going to be minus, let's see, that's going to be 1 over 101. What is negative 1 to the 101?
Negative 1.
That'd be, yes, negative 1. Because remember, if we do a negative number to an odd exponent, we get a negative answer. And so then, basically then, that's meaning that it's going to be a negative 1 over 101 there. Still plus c. All right, now if I now get rid of those parentheses, I get 1 over 101 plus c minus a negative, so that's going to be plus 1 over 101, and minus c. Notice that minus gets distributed to the c term as well, which ends up being actually really important in this because it's going to tell us something. So I have 1 over 101 plus 1 over 101. That just gives me 2 over 101, right? But then I have this c minus c. And what's c minus c going to give me? 0. They cancel each other out, which shows that no matter what ends up getting put on the end, when we find the antiderivative, it's going to cancel itself out because I just went ahead and left it as the general c and it canceled itself out. Therefore, when we do these antiderivatives to find an integral value like this, you actually don't even have to include the plus c. And the future problems that we're going to be practicing today, you're going to notice that I'm just going to include this part of the antiderivative. I'm not going to include the generalized plus c at the end because I know it would cancel itself out. And so then this 2 over 101, that's my final answer. So the first thing you do is you find your antiderivative. Notice in this case, it's f of u because all of this stuff is being done in regards to the variable u. So always keep an eye on which letters they are in your particular problem. Then we're going to have to take that equation and do capital F of 1 minus capital F of 0. So in other words, plug 1 in, plug 0 in, subtract the values. And so we plug in our values, but the nice thing about this one is, since we're going from 0 to 1, a lot of these calculations end up being very easy. So we're really doing 1 plus a 10th minus a 25th. Because you'll notice that this whole part that I'm subtracting, every single piece of that equals 0. And so it's just minus 0, so that goes away. And then go ahead and figure out what that equals, either as fraction or as decimal. Either one would be fine. You should get as an answer 1 3/50, or if you went into decimal, that would be 1.06. Either way is fine. Now, one little side note, for some of these problems, this line can start to feel a little bit unwieldy for some of us, because there's so much going on in it. If you want to make your life a little bit simpler where each line is a little bit shorter, another option for how you can show your work is after you write this line, have a line that says f of 1 equals, and go calculate that out. So like in this case, you do all those calculations, you get your 1.06. Then you do f of 0 equals, that equals 0, and then you just do the 1.06 minus 0 on the line after that. So it's the same thing as what we did here in one big long algebraic step, but just breaking it down into a little bit more manageable pieces if you prefer. Either way is fine. All right, so in this case, we need to find the antiderivative again, but before we do so, we don't have any tools on how to be able to find the antiderivative of that from that form. But we can if we expand it out. So the first thing I'm going to do is I'm going to rewrite my integral and actually multiply those out. That would give me 2y squared minus y minus 1. And now you can go ahead and go on and find out what the antiderivative equals. And so this is what your antiderivative should be looking like. And so when all is said and done, we plug in the 2 into our antiderivative. We take away the antiderivative at 0. You end up getting 4/3 as your final answer. So as you go to take the antiderivative in this case, we're finding the antiderivative of secant theta tan theta. Now, yes, they're multiplied, but it's not like we're having to use inverted product rule or something like that. This is actually a known derivative. Secant theta tan theta is the derivative of what? Secant theta, yes. And so then we can know then that the antiderivative of theta is going to just be secant theta, because the derivative of that is secant theta tan theta. All right, and so as we go to find these values and go plug them in, I'm using the fact that secant equals 1 over cosine. And so then we need to actually find out what this equals. And yeah, I'm going to go ahead and leave it in an exact form, at least for a little while. And this is a little refresher that you can see here on the right side about how we actually do that work. This is review from last year, but haven't had to do it a whole lot recently, so it's good to practice and see. But we end up seeing that equals root 2. And so we're doing root 2 minus 1, which if we're giving our answer in exact form, we'd be done there, because that's as good as we can make it. Or if you want to get the decimal approximation, that's going to be about 0.414. And then for this one, I'm showing the work just slightly differently using that method I was talking about earlier. I'm just figuring out what's f of pi, then I'm figuring out what capital F of 0 is, and then I can actually do the capital F of pi minus capital F of 0 at that point. And so when we do that work, we end up finding that we end up getting about, or we get exactly 5 minus e to the pi. E to the pi, that's an irrational constant to an irrational constant. Doesn't exactly come up a whole lot. So you're definitely going to need your calculator to figure out that value if we're going to give a rounded answer. It would give you about negative 18.14.